Good evening. We are going to prove that no integer in this sequence 11, 111, 1111 is a perfect square. To prove this with the help of Euclid's division lemma is not a challenge. Very easy to prove that. If we consider divisibility of a number by 2 and then consider square or consider all the integers in that form only, then it will be easier. Just to remind you, Euclid's division lemma, when you consider divisibility by 2, that any integer a can be expressed as b into q plus r, and when you divide by 2, then it will be of the form a equal to 2q plus r. This r has values 0 or 1. So integers can be expressed in this form 2q plus 1. This you are doing from very beginning of your academic classes. In fact, from class 3-4 only, you know integers are odd and even. This is even and this is odd. So if an integer is even or odd, then its square going to be what? What form will I get if we make square of this thing? That is expressed in this problem. Prove that every square can be expressed as 4k or 4k plus 1. Let me give you the proof of this thing first. Square of integer is of the form 2q or 2q plus 1. If we take a equal to 2q, case 1, for a equal to 2q, a square stands for what? 2q whole square. This is 4q square. You can write this as 4 into 4q. Now 4q is an integer. If we take k equal to 4q, then a square is going to be 4q. But this is for a equal to an even integer. What happens if we take a equal to 2q plus 1? Let's see. A square going to be 2q plus 1 whole square, which is nothing but 4q square. 4q plus 1, 4q into q plus 1 plus 1. If you take q into q plus 1 as k, this is going to be 4k plus 1. Okay, that a is 4, a square is 4k plus 1. What k stands for? K will be q into q plus 1. Okay, so you all can see that integers are of the form 4k or 4k plus. I mean perfect squares are of the form, not integers only. Perfect squares are of the form 4k or 4k plus 1. Let us do the experiment with few perfect square numbers 1, 4, 9, 25, 16 also there like this. Then 1 is of this form. It is perfect square, and we can write this 1 is equal to 4 into 0 plus 1. How to write 4? 4 is 4 into 1. So this is of the form 4q or 4k, and this is 4k plus 1. What about 9? This we can write 4 into 2 plus 1. This is of the form 4k plus 1. What about 25? This we can write as 4 into 6 plus 1. So this is of the form 4k plus 1. This way, if you express all perfect squares, can be expressed either of the form 4k or 4k plus 1. Now go back to the problem we are going to discuss here. No integer in this sequence is a perfect square. If they are perfect square, if integers are perfect square, just to prove that, they will be of the form 4k or 4k plus 1. Question is that, are we getting of the form 4k or 4k plus 1? Let's check. 11 is nothing but 4 into 2 plus 3. This is not of the form 4k or 4k plus 1. which form 4k or 4k plus 1. What about 111? This we can write 4 into 27 plus 3. This is also not of the form 4k or 4k plus 1. 1111, how to write? This is 4 into, like this. This is also not of the form 4k or 4k plus 1. So all the integers in this sequence are coming to this form 4k plus 3, and 4k plus 3 you can never express in the form 4k or 4k plus 1. So no integer in this sequence is a perfect square.